All right, let's get started. I think people will kind of come in as they get time, but
Okay.
I think I definitely really want to enjoy the conversation. After looking forward to what you have to present, but also looking forward to hearing from everybody else and kind of having a general conversation around this and how it works for Northeastern. So, without further ado, my name is Jacob Blickel. I'm the Director of Sustainability Communication and Integration in the Office of Sustainability within Facilities Management. And I'd like to welcome everybody to our speaker series here with Gilbert Delgado. He's the Associate Vice President for Design and Construction in Facilities Management. And he's going to talk to us about building sustainably in general, and kind of some of the new things that are coming around on the market, but also how it really applies to Northeastern and what we're trying to work on here. And in general, think about your questions. You can put your questions in the chat as we go through, but we're going to leave definitely a lot of time to have a good discussion about building sustainable buildings in general, but also how it works for here. Anybody has any additional questions about sustainability or unrelated to this, please reach out to me. I'd like to have those discussions. But without further ado, I'll turn it over to Gilbert.
Thank you, Jacob. And this is a very interesting topic because, of course, climate change is such a significant issue of our time. But what really is alarming or quite a challenge is the role that buildings play in this issue. And that's what I want to maybe leave you with an appreciation in terms of what is our responsibility as those involved in the building industry, and also what are some of the things that are happening of keen interest around the world. So with that, I'll get started. Oops, it's not advancing. Okay, so a lot of this stuff is probably well understood by many, but looking at it through the lens of what it means to the building environment. Currently the world is about, oops, it's disappeared there. The average temperature of the planet is about 1 degree higher than it was in pre-industrial levels, or roughly around the 1960s was the last, let's say, baseline of zero. And as you can see, it's been going incrementally up, goes down and up in terms of with the seasons, and then it finally gets up to about 1% back in 2016. So we're currently at that threshold. At 2%, if this were to continue and the temperature change were to increase 2% above that baseline, we understand that coral reefs will start to disappear. The Mediterranean will experience widespread desertification. So all the things that we've come to love about the Mediterranean much of it will be gone, and that is to be of a serious concern to everyone on the planet. And then at 3%, it's been said that 760 million people will be displaced due to sea level rise, and primarily some of the major metropolitan areas on coastlines are all at threat. So therefore, the challenge is let's see what's coming up here. Wait, this exactly. Oh, here we go. The challenge is an imminent threat in many ways, and to maintain a 1.5 degrees Celsius rise, we can only emit 340 gigatons of CO2 to the atmosphere. So we know what that. So we've quantified that volume, and therefore to reach that, we now have what we understand is to be a definable target, which is a 65% by 2030. Now, this is where our responsibility comes into play. If you look at the CO2 emissions on the planet by different enterprises, the building enterprise takes up roughly about 40%. I'm sorry, this, can we go down here? Okay, so as you see the chart on the right, about 28% of it is based on building operations, and that is the amount of carbon that is generated by people turning on the lights, heating and cooling their buildings, and operating their machinery. An 11% is based on energy that was in the building themselves, in terms of energy that was required to actually build the building. So together they comprise about 40%, transportation is about 23%. And just to reiterate, we must reduce the CO2 emissions by 65% by 2030, or the climate change will be irreversible. That leaves us 8.5 years to meet that target. The other sobering reality is that the building stock of the planet will double in about 40 years. So we need to reduce our carbon greenhouse gas emissions by 65%, and at the same time, we're going to be increasing our building stock. And in some ways, we see some of that on our very own campus. Even though we are challenged to reduce our amount of carbon that's being emitted, we are also increasing the size of the campus significantly. And this is something that is mirrored on a global scale. So looking at how buildings more specifically use carbon, again, about 10 to 20% is the embodied carbon in the building, and 80 to 90% is the operation, and that is specifically heating and cooling, lighting, electrical equipment and appliances, and then the embodied energy being the blue pie slice. So switching gears a little bit in terms of what is the overall challenge, Northeastern University has been committed to LEED, and LEED is the worldwide established standard for how to actually reach measurable and certifiable objectives in the realm of sustainability, and not just energy and carbon, but also water and materials. And as you can see, the number of projects that have been accomplished over the last several years in which meeting LEED certification targets, many in the gold range, and many major projects in the gold range. I'm going to take a quick look at specifically two of these projects because they are large and because they are innovative in the way that they actually address the sustainability question, and perhaps more specifically, that if you look at sustainability, the most urgent thing that is right now on our horizon is the need to minimize global gas emissions. So the ISIC building is one that is clad in the building skin is shaded by fins that actually result in a 78% reduction in the heating peak load. And for those of us that have studied how buildings use energy, keeping sunlight off the glass is one of the most effective ways to reduce the burden in terms of heat gain. So it's a costly approach, but a very effective approach. And this particular example, they've used it to create a sculptural reading of the building that makes it quite beautiful. Other ideas that were employed in ISIC resulted in the building being 50%, utilizing 50% less energy than the building code requirements. And it does this through a variety of means. One is the utilization of high efficiency fume hoods. Those of us that have been working with laboratory buildings understand that, in fact, these are the energy hogs of any campus. If you look at any university and you look at the amount of BTUs per square foot across the campus, the highest ones are always laboratory buildings because of the amount of air that they need to dispel, and that air is usually warmed, right? So it's energy that's warmed and then expelled very quickly. So having high efficiency fume hoods that either A, shut down when they're not being used, or B, have innovative ways to actually exhaust the air are very effective. Chilled beams is another way to actually reduce the amount of energy that is utilized by a building. Heat recovery, where heat that is being generated through the building process is actually utilized again to heat the building. So it's another, and in the case of ISEC, there's a large atrium, and this atrium is used as a mixing box, which actually takes some of the exhausted air out of the labs and actually uses it to ventilate the non-laboratory spaces. Again, the air has been heated, so that the energy to heat that has actually been eliminated or reduced. The EXP building that is currently under design is currently being designed with LEED as its target. We know for sure that we're going to get gold, and we are actually targeting LEED as our target. Again, it employs a shaded building envelope, and this also helps with heat gain in the summer and keeping and minimizing the need to cool the building in the summer. It uses high efficiency lighting. As you saw from the earlier chart, lighting is one of the most demanding energy requirements of typical buildings. So having high efficiency lighting is very effective. Enhanced lighting controls that actually turn off or allow the attenuation of lighting for its needs. So we're not overlighting the building and actually only lighting the spaces that we need. Again, using reduced lab airflow and exhaust as a way to minimize the burden of the mechanical system having to heat and cool air that is going to be moved out of the building very quickly. Lab exhaust energy recovery, again, air that is already heated is being utilized to heat the building. High efficiency chilled water plants and boilers, all resulting in a building that will be utilizing significantly less energy than a baseline building of its type, which is one of the LEED targets, which is in the energy model, you develop a baseline building and you compare the building that you're designing against that baseline, and having to reduce a significant amount below that target to actually get that LEED point. So now I want to talk a little bit about a stretch goal, right? What is beyond LEED? What is going out there in the industry that can actually be model buildings for us to actually think about in the future? And the first thing I want to talk about is net zero, which are buildings that produce as much energy as they utilize in 1 year. So basically that consists of reducing the energy demand by having more efficient appliances, minimizing the heat load through smart shading of the windows, and then by producing energy locally through renewables. So on the top, you see a commercial building in Seattle, and you can see its photovoltaic screen up above. And roughly, it used to be, and photovoltaics have become more and more efficient as time goes by, but it used to be that you needed 1 square foot of photovoltaics would actually be sufficient for 2 square feet of building. So roughly, if you had a 2-story building, in the roof itself for photovoltaic, that would be a reasonable and realistic target for meeting net zero. That's why net zero is not a very good model for high-rise buildings unless you have a photovoltaic farm or some other way to generate power remotely. But then again, then you don't meet the target for on-site renewable. So therefore, it's usually reserved for mid-rise buildings. But we're talking about buildings that at the end of the year did not consume any more energy than they produced. Energy use equals energy production. I worked on a building that, a pretty ambitious building that actually was net zero, and this is the Bloomberg Center at Cornell Tech. As you can see, architect Tom Main integrated the photovoltaics into a sculptural element of the building. But there were other things that had to happen to actually meet that sustainability target. One of them was, hold on. We installed 8,400-foot deep closed loop geothermal wells to heat and cool the building. So that actually reduced the burden of the photovoltaics being the only thing that would actually provide the renewable energy. We had 1 acre of solar panels. And then some smart building link controls, because part of the equation is to minimize the demand side. So having a system that actually turns off the lights every time someone's not there is very important. The building's about 160,000 gross square feet. It had a 40,000 gallon rainwater harvesting tank. Not specific to the net zero objective, but a sustainable approach to minimize the use of water. One thing was
We're going to be talking to Paul also over at ISEC. I ran into Alham because I was over there getting ready for the tour from the Millis College folks, and they're doing the tie-in between EXP and ISEC. Okay. And so there's a team of contractors working in the basement of ISEC, and they core drill through.
Okay. Okay.
So they'll have
Okay. Okay. Sorry. Okay. Okay. So then another example of a strategy that I want to talk a little bit about is passive house. And passive house is a standard that was developed in Europe as a means to greatly reduce the amount of energy that is required to heat, cool, and operate buildings. And basically, I have a little picture of a thermos on the left hand, because that's kind of what it does. By hyper-insulating buildings and making sure that whatever heat or cooling is produced, it stays in the building. And this results in an 80% less energy than conventional construction. And as on the diagram below, you could see a thermal image, right? And on the left is in a traditional building, and you could see where the heat escapes out the windows. On the right is a passive house building, and you could see how much better insulated that building is. So some of the basic tools that are employed in reaching these very aggressive targets. One, solar orientation is very, very important, because you want to be sure that you maximize. Every time I move my mouse to show you something. Okay. So solar orientation is vitally important to capture the warmth of the sun in the winter and to control it in the summer. This is basic passive heating and cooling strategies, but one needs to understand that windows are notorious transmitters of heat and cold, so it needs to be very carefully modulated. High insulation to a very high degree, high performance windows, airtight enclosures. One of the things that is part of the passive house testing process is to set up in situ air infiltration test to be sure that the building is hermetic. So it's a very effective strategy, one that was also employed at Cornell Tech. This is the residential tower, 352 rental units. It's the tallest passive house building in the world, LEED Platinum. Now, the last bullet here is what I find really interesting, because one thing is to talk about these strategies, and then the question that probably comes to a lot of people's mind is this economically feasible? And we were working with Hudson Related, which is a large developer in New York City, and we told them that we had this objective of Cornell Tech being kind of a flagship for sustainability in construction. And they were a little bit skeptical at first. So we went to Austria, where passive house is actually a maturing industry. And they were actually really impressed. What really impressed them was that using 80% less energy translates into reducing their operational costs, right? And if they reduce their operational costs, it results in greater profitability, especially since there were long-term investors in the building. So, you know, there was an interesting article in the New York Business Journal saying that, you know, that this building was a watershed in terms of demonstrating how aggressive sustainability measures can actually be, you know, wise business decisions. So one thing of also interest is if you look at the banding, the lower picture, you know, windows are the amount of glazing has to be very strategic, because glass from floor to ceiling is a horrible insulator. So basically, you know, you can have glass, but they have to be, you know, very well very well placed and very strategically employed. If you look at the base of the building, it's all glass because that's where the building meets the ground, and that's where you want to have an inviting presence on the site. But as the building on the upper floors, you know, using the black band gives the appearance that the windows are larger than they are, but in fact they are controlled in terms of scale. At the University of Toronto, we also did a passive house building, this time 750 beds, and it also included dining, which was quite a challenge because of the high energy demands of kitchens. It also included student services. And here again, we had a third-party co-owner. Fengate is an investment house in Canada, who actually was majority owner of the building for at least 30 years, for the time of the land lease. And they actually, again, determined that an 80% reduction in utilities would actually be a very wise business choice. And they were actually in it with us all the way through, and very enthusiastic participants of the design process and of the objective of providing a building that actually would be a signature building in that industry. And then the third thing that I want to talk a little bit about was, we talked a little bit about how there's two parts of how buildings utilize carbon. And one is in the operation, and net zero and passive house are primarily examples of how to reduce the operational footprint. Now I want to talk a little bit about how to lower the embodied energy footprint, and that is cross-laminated timber construction. And this is the use of wood to build high-rise buildings, which most building codes until very recently only went up to 5 or 6 stories in terms of using allowable wood construction. We're talking about going much higher than that. And concrete and steel emit about 13% of the world's greenhouse gas emissions. So therefore, thinking differently about how to build taller is really worthwhile. When I was living in Canada, of course, this is of great interest to Canadians that have a pretty large surplus of timber. And this is the time of the steel tariffs of the last administration. So this was actually something that the government itself was promoting, and actually provided the University of Toronto with some subsidies to actually explore this as a technology. It's a relatively new industry in North America. So it's not just the availability of the cross-laminated timber, but also the connections that connect the beam to column, enclosure system to structure. Those have to be steel, and those connections are at the time that I was working on this project was something that was being kind of an infant industry. 2 tons of carbon, 2 tons of CO2 are emitted in the production of 1 ton of steel. I mean, for those of you that know how steel and concrete are produced, you know that really high temperatures are required to do that. And in the case of wood, nowhere near the amount of fabrication carbon that is required. The way it works is, most of us are familiar with glulam on the right. On the left is the cross-laminated timber approach, gets its strength from crisscrossing wood and gaining structural strength that way. the world's tallest building, they call it a ply scraper, is in Norway. It's 18 stories tall, and it just recently was completed. It's a residential building. Brock Commons at the University of British Columbia is an 18-story student residence. So demonstrating that in fact it's a viable option also for universities and university housing. And as you can see, there's some other benefits aside from the carbon emission avoidance in the fabrication and production. One, as you can see, it also benefits from prefabrication advantages. The wood planks arrive on site. There's no need for the concrete on a deck to cure, right? So once the deck is laid down, the workmen can actually get on their knees and work on it immediately. So there's a construction speed and also quality assurance that happens when these things are actually manufactured in a shop as opposed to on site. Another interesting advantage of timber construction is that some fire codes have not gotten to this point yet. An interesting aspect about timber construction is that most of us think, well, what about fire, right? And traditional building codes use gypboard as a way to provide fireproofing for this type of construction. But the fact of the matter is that if you take a blowtorch, let's say, to a small piece of wood, yeah, it'll ignite. But try doing that with a very large piece of wood. So cross-laminated timber actually has passed several fire tests. What happens is that the outer part of the wood gets charred and protects the core of the structure. And it has roughly the same amount of fire resistivity as structural steel, which actually melts when the temperature reaches a certain temperature, a certain level. Project that I worked on in Toronto, at that time was supposed to be the tallest building. It's, I think, the tallest building in North America. I think it's under construction now. We benefited greatly because the government, the Canadian government, was very interested in promoting this industry. So we actually got a pretty significant subsidy from the Canadian government for design and construction. You can see it's a very, very elegant building, an interesting case study. We also worked at a smaller scale in Toronto. We had a strategy called Laneway Housing, which is actually building small houses in alleyways. These we also did utilizing passive house standards or certified passive house. So demonstrating that at 2 scales, it can actually be a very realistic approach to building. So looking at what's coming down the pike for us, many of you might know of Article 37 that the city of Boston defines their sustainability objective. There are compliance submittals that includes sustainability narratives of lead targets, climate resiliency checklist, an energy model, and a renewable energy strategy with supporting analysis. Like, they want to know why, have you examined photovoltaics, and why aren't you using photovoltaics, right? So there's a drive on a municipal level to actually drive some of these requirements, and the check for these requirements this happens at the initial filing when you pull the design build permit, and before you get your certificate of occupancy. So it's becoming more rigorous. One of the things that they are moving towards is, so far we've had reporting requirements in terms of what is our energy utilization for our individual buildings. but they're now moving towards establishing absolute limits for different types of buildings and for a campus that we will have to demonstrate how we're complying with. So so all these strategies that I mentioned might actually be instrumental in us being able to achieve those targets, especially as we build new buildings. And with that, I'll open it up for discussion.
Great. Thank you very much, Gilbert. This is a great overview, great information about what we're doing here. There's a lot of questions I have already, but let's start off with, I think Tori had one in the chat. I guess what she talked about the range of heights. Yeah, so her question was, there a range of heights during which cross-laminated timber makes the most sense? And I would say most sense around here. Maybe just apply it more specifically, like what could we see around here, what the building codes would allow around here, and maybe.
Yeah, well, believe it or not, there is an 80-story tower being planned for Chicago using cross-laminated timber. So there are some folks out there interested in pushing the envelope. When I was in Toronto, I believe the standing limit was like 6 stories tall in terms of wood frame construction. They didn't really treat cross-laminated timber just yet. We were going to go for 14 stories. And part of why the Canadian government was giving us that money was that they wanted to use our project as kind of a test case to move the building codes to actually modify their requirement. And we were working with the fire department to actually do that. So I would say that at a minimum, I would say a dozen to 14 stories is certainly doable. I'm not sure where the city of Boston lies in terms of that particular issue. Like what is the current building code and how open are they to looking at high rises? I know the city of New York has a couple of residential towers that are cross-laminated timber. But I do know that Chicago has one on the drawing boards now that's 80 stories.
So folks have any other questions for Gilbert, please come on, raise your hand, put it in the chat. Just make yourself, turn your video on. I'll know you're interested in asking a question. I would ask for me, I mean, you're relatively new. You've been here, 2 years?
Year and a half.
Year and a half? Time does fly. So I guess what, just some of your experiences here, like what, you have obviously a great background working in a lot of different universities and projects, but what are some kind of the opportunities and challenges you've been, that surprised you or you're excited about here at Northeastern?
Well, I think one of the great opportunities is that we're a campus that's kind of on the move and growing, right? So I think that to the extent that we embrace some of these possibilities, and sometimes it's just that, right? At Cornell Tech, the dean of the School of Architecture just basically planted the seed and said, why don't we do something innovative? Why don't we do a net zero building, right? So, and at the time, well, the goal was to stretch a net zero campus. And we quickly realized that was impossible because we wanted to do high-rise buildings. And that would be really, really difficult. So we decided on doing one building. So I think the fact that we have some aspirations to grow the campus, I think that there's that possibility. The other thing that's interesting is that with the city of Boston actually establishing energy utilization thresholds, right? That we might need to think outside the box in terms of how we renovate our existing buildings and maybe look at some of these strategies to come up with things that are even beyond LEED.
Yeah, just a little more background on that. The city of Boston, city council just filed a new ordinance regulation law. Can't remember the exact titles they used, but to require buildings in Boston to meet a greenhouse gas emissions threshold. We already required to report our emissions, and this is kind of the next step of setting some targets and kind of rationing down over the years. We are definitely good performers in general, so those we wouldn't be kind of the first target for the emissions, but eventually, as you said, we're going to have to start thinking more creatively about how we meet them. Any other questions out there? Thoughts about ideas of what we should be doing on campus, or things people have seen in their own work or in passing that you're curious about, what we're doing here? Question from Casey Shetterly. Are you familiar with carbon cure? Utilizing captured carbon to mineralize concrete. It's the way to sequester carbon within the concrete process of making concrete.
No, I haven't heard of that.
Any follow-up to that, Casey, or?
Yeah, I was just reading about it and about new opportunities for workarounds in the building materials. And I was just curious about it because it was new to me, and it's a Canadian company, so I thought you might be familiar with it.
Yeah, I do know that this is really interesting. I thought, we got a lot of press for the tower we were working on. And we said a lot of things about cross-laminated timber and its carbon and what an improvement it was over old building types. Well, wouldn't you know that the other folks that are involved in the other industries weren't taking that lying down. So I got some pretty serious phone calls from folks in the concrete and steel industry. Pretty much one was saying that, well, what could be more sustainable than pulling gravel out of the ground, right? I mean, that's just, and it's there's gravel everywhere in Canada, right? So whereas wood might be trucked in from a distant location, right? So there were vested interests that I think that were either threatened or, we're actually looking at ways to look at this question very carefully. So anyway, I do know about that, but I haven't heard about this technique.
I think gravel everywhere. Forget that. It's pretty intense. Yeah. It's pretty intense to process, but there is gravel everywhere. I see Lynn. You had a question. Do you want to ask it yourself, or should?
Yeah, is laminated timber construction more difficult than structured steel? Well, it's like everything that's new, right? I mean, I do remember that when I was in Toronto, this whole notion about, well, where will the connectors come from? And is there adequate supply for a building of this size, right? So it is new, right? And you have to, one thing that they used at Brock Commons in British Columbia was they actually did the building in Revit, right? And then they actually, using BIM, actually walked the contractor almost step by step in terms of how to fabricate this thing, right? So you have to work very closely with the folks that are developing the prefabrication elements and the builder to be sure that they're actually in sync in terms of how to deliver the building. So it requires, I think, a bit more thought in terms of the construction process, just because it's new, right? I think as things become more accepted, then they might actually be. Now, that being said, they are, I think the Brock Commons in British Columbia was built faster than a traditional building because of what I said. When you do a steel and concrete building, you lay down the steel deck, then you pour the concrete, and you really can't walk on it immediately. There's a certain sequencing of the work that if you just lay down a wood deck, right, and connect the pieces like a piece of IKEA furniture, then there's some benefits of that. Additionally, if things are fabricated in the shop and they come in as assembled pieces, like wall systems, right, that minimizes a lot of the on-site activity. So I'm cautious to say that it's a win-win because it's a new industry and some things have to be worked out. okay, or cost more. Actually, one of the things that the Canadian government asked us to do was to quantify if there was any kind of cost premium. And at that time, there was, I think, about a 6% cost premium over traditional construction. And they were going to give us that 6%. So,
Always nice.
yeah, they really wanted to promote that as a national industry. Okay.
Have there been more people following your lead after that, or is that?
I don't know. There was the Brock Commons that was before us, and then there was this one in Ontario. So I don't know of any other major wood building.
Yep.
Okay, Gilbert, is it still the case that the greenest building is the one that you already have, or has the demolition building technology changed that thinking? Yeah, I think that, well, the greenest building is the one you don't build, right? I mean, and I think that, that's an interesting question, is that, in our society, we have buildings that we sleep in, we have buildings that we work in, and then we have buildings that we shop in, right? And all three of them have to be usually air conditioned and heated, right? So yeah, in some ways, not building space that you don't need or underutilize is no matter what you do in terms of building technology, you still have to heat and cool everything you own. So the greenest building is the one that you don't build. That's funny coming from an architect, but I think it's true.
Tori, do you have a question?
Yeah, thanks for this presentation, Gilbert. You've shown some really beautiful examples of new buildings and different ways of using technology. And I guess it's a little bit of a follow-up from the last question, but I'm wondering what you've seen recently that you've been excited about, or you think is really effective for and creative solutions for retrofits of existing buildings.
Yeah, I'm glad you asked that. One of the things that I was really interested in when I was working on the timber construction is it's also a lot lighter than steel and concrete. So this idea that you might be able to expand existing building stock by building 2 or 3 stories above them, right? And then the load on the structural system will be such that it can be accommodated. I thought was an intriguing question, especially in like urban landlocked campuses, right? So I think that's quite interesting. And I think also the passive house paradigm is something that we need to really, if buildings are responsible for 40% of the greenhouse gases, and there's a way to cut 80% of the energy, right? Then it's irresponsible not to look at that carefully. So buildings that are very glass intensive, I think the city of New York actually now has, and it got a lot of flack in like conservative media for like building, do we really want to build buildings without windows? Well, no, it's not building buildings without windows. It's building buildings that have windows in the right places, not just indiscriminately applied across everywhere. So I think those are things that we actually have to be pretty mindful of.
With the heat wave coming around here and everywhere else, it seems like you talked about the kind of solar skin for our EXP and ISIC. Where do you see some of the kind of increased challenges around the heat gain and trying to prepare these for these extremes?
Yeah, well, the same things the same thing. Glass is susceptible to heat gain and also susceptible to energy loss in the winter, right? So we did a study when I was at Cornell about a facade master plan study, and basically and it's kind of the industry norm that you should have no more than 40% glass to 60% wall ratio in your buildings, and then how you use that is key, right? So you want to, like I said, in the example of the passive house building in New York, you want to have a transparent base because you don't want the building to be cut off from the ground plane. So that takes up a big percentage of that amount. The other thing that you probably want to provide transparency in are things like the elevator lobbies, right? So they're actually expressed in some way and connect to the rest. So then what that means is what's left has to be really well thought up of, right? So how the upper floors utilize glass is really important. So I think that hyper insulating, being very careful about the use of glass, and the other thing which is necessary in passive house construction is to be mindful of heat transfer, like the way a wall system is connected to the structure using clips, metal clips, and those metal clips are where the heat actually flows out to the general environment. So, I think what passive house has done has made us at least think about how to create a hyper insulated building. We might not always be meeting that passive house standard, but we certainly should be, we should actually learn from those strategies.
Excellent, thank you. Any additional thoughts or questions out there? If not, this has been great. I'll give everyone a few minutes back on their day here, and please follow up with myself or Gilbert. And if you have any additional questions or comments, we would love to hear from you. So Gilbert, any last thoughts before we sign off? Or?
No, thank you so much for being given this opportunity. Like I said, it's a serious charge. And those of us that have the opportunity both now and in the future to have leadership, right, need to actually try to inject this in the conversation, because sometimes the way of doing things in the conventional way is what controls the conversation. And sometimes it just requires someone raising their hand and saying, hey, how about passive house? Hey, how about, net zero? Or hey, how about cross-laminated timber? Because in my experience, that's how these things happen. It's someone just saying, why don't we do this, right? And getting enough traction. And it's sometimes difficult at the beginning, but it actually, as you're into it, you realize that in fact, it was a smart thing to do.
Excellent, I completely agree. All right, well, thank you everybody for joining, and stay cool. We'll continue. We have some, we'll be doing this speaker series was inspired because we are putting on a fall course on sustainability and resilience, covering topics like these. It'll be a class for students, and I'm hoping to expand it to anybody in the community can join. So look out for the fall, a lot more robust programming around sustainability and resilience activities occurring on campus. All right, have a good rest of the week and have a good holidays this weekend. Thanks everybody.
Thank you. Bye-bye.
Thank you.